So you've probably heard it a million times, just use Flow, right? Or make sure you use StateFlow for UI state. Or maybe SharedFlows for events and Channel is for navigation. But honestly, if someone sat you down right now and said, okay, pick the right tool for this job and explain exactly why, could you do it? Well, most Android developers actually can't. And it's not because the APIs are super hard. It's really just because nobody ever sat down and explained how they all connect together. So that's what we're doing today. This is the complete Kotlin Flow and State mental model. We're going to cover every single concept in every relationship in under 5 minutes. Let's get into it. Android Atlas. Section 1. Flow. Values moving over time. Cold. Lazy. Triggered by collect. All right, let's start with the core problem here. You know that a standard suspend function just returns one answer and then it completely stops. But in the real world, data keeps changing. Think about things like location updates, live search results, database rows, or maybe a sensor that's taking a reading every single second. You simply can't model that kind of ongoing data with a single return value. And that's exactly where Flow comes in. Flow is Kotlin's answer to this. It's basically a stream of values arriving over time. But here's the absolute critical rule, and honestly, this is what trips everyone up. Flow is cold. That means you can write a flow, stack 5 different operators on it, pass it all around your app, and absolutely nothing runs. Literally nothing. Because the pipeline you built is just the description. It's not an execution. The actual trigger, that's collect. That is your terminal operator. The very moment collect is called, boom, the flow starts, emit produces each value inside the flow block, and collect receives them on the other end. So the rule of thumb, build the pipeline first, then pull the trigger. Section 2. Operators. Transformation pipeline. We're looking at map, filter, debounce, flatMapLatest, combine, and zip. So what happens between emit and collect? Well, that's your pipeline. Think of map as the tool that reshapes each value. It stays in the exact same position in the stream, but it takes on a completely different shape. Then you have filter, which essentially decides whether a value gets to continue at all. It's like a bouncer. It either lets it through or blocks it entirely. Now, debounce is super handy. It basically waits until things go quiet. If you type hello in a search box without it, you've just fired 5 separate network requests. But debounce collapses all of those into just one. Then there's flatMapLatest. This one is a real game changer, because it cancels stale work the very moment new input arrives. It's the perfect fix for that annoying search race condition, where your first result actually arrives after the second one. What about combining streams? Well, combine always pairs the absolute latest values from 2 completely independent streams. On the other hand, zip is much stricter. It pairs them up exactly by their position, and actually waits for both to be ready. The key takeaway here isn't to memorize 20 different APIs. It's really just one core idea. You're describing what to do with each value as it passes through the pipe. And remember, this entire chain only runs when it's collected. Absolutely nothing happens sooner. Section 3. State. A different question. It's all about what's next versus what's now. Now, here is the pivot that's going to make this whole thing click for you. You have to understand that flow and state answer fundamentally different questions. Flow is always asking what arrives next. But state is asking what is true right now. State is always just one single snapshot, the absolute current version. When a user opens up your screen, they really don't care about the history of the data, right? They just need to see the current situation, immediately. Now, if you give a brand new collector a cold flow, it gives them exactly nothing at first. It just sits there and waits for the very next emission. So if the last network response came in 10 seconds ago, your new collector is going to miss it entirely. That right there is the gap, and that is exactly why StateFlow exists. StateFlow is basically a flow that always holds exactly one current value. It's readable the very moment you subscribe. No waiting around, and no coming up empty-handed. Section 4. StateFlow and MutableStateFlow. One state, 2 keys. The ViewModel writes and the UI reads. Okay, so StateFlow by itself is completely read-only. MutableStateFlow, as the name suggests, adds write permission into the mix. It's the exact same underlying state, just with 2 different access levels. It's a lot like a Google Doc. You have a viewer and an editor, but it's the exact same document. In your code, it looks like this. The ViewModel declares _UI state as a mutable state flow. It's more private, meaning the ViewModel is the sole owner. Then it exposes UI state to the outside world as a standard state flow. This means your UI can read it and it can collect changes from it, but it can never, ever write to it. One owner updates it and everyone else just reads it. This is a crucial permission pattern, and spoiler alert, it repeats. You're going to see this exact same structure for events in just a moment. By the way, every single concept in this explainer has its own dedicated short in our 29-part playlist. 29 shorts, each one under 90 seconds, breaking down one mental model at a time. I've linked the whole thing in the description below. Section 5. Shared flow and channel. Events. We're comparing share versus deliver. So, as you know, not everything is state. Sometimes, things just happen, and the UI simply needs to react, not replay a past state. Imagine a payment succeeds. The UI needs to show a quick success banner, your analytics tool needs to log the event, and the system logger needs to record it. That's one single moment, triggering 3 completely independent reactions. And that is where SharedFlow shines. With SharedFlow, one emission fans out to every single active collector simultaneously. And it uses that exact same ownership pattern we just talked about. You use mutable SharedFlow to emit things privately, and you expose a standard SharedFlow for your observers. It even has a handy replay parameter for any late collectors, just in case you need them to see the last few emissions when they finally subscribe. But what about something like a one-time password? An OTP has exactly one intended destination. Broadcasting that out to analytics would be completely wrong. It's actually a security issue, and frankly, a total misuse of the pattern. For that, you need a channel. A channel is strictly point-to-point. It's one send, one receive, and the data is consumed exactly once. Think of it like a courier delivering a parcel to one specific door. They don't go knocking on the neighbors' doors. So your decision rule is simple. If multiple parts of the app need to react independently, use SharedFlow. But if it has one specific destination and should only be consumed once, definitely use a channel. Section 6. StateIn and SharingStarted. The bridge. This is all about converting a cold flow into a hot state flow. Here's a super common scenario. Your repository returns a standard flow. Maybe it's from Room, a network stream, or a hardware sensor. But your UI needs a state flow. Right off the bat, these are incompatible shapes. So StateIn is your bridge. It seamlessly converts that cold flow into a hot state flow, all without touching the original source. You can think of it kind of like a fast-moving news ticker feeding data into a fixed display board. The ticker is streaming all this raw data, but the display board just holds and shows the absolute latest update. You also have initial value, which basically covers that awkward gap between when you first subscribe and when that first emission actually arrives. So you might show loading state while the real data is on its way. Then we have SharingStarted, which dictates exactly when the upstream flow should actually start being collected. You've got 3 main strategies here. Eagerly means it starts immediately the moment it's created. Lazily means it waits patiently for the very first subscriber. And while subscribed means it only collects while there are active observers and stops as soon as they're gone. Honestly, the default you should almost always reach for is while subscribed 50,000. Why the 5,000? Well, that 5-second grace period lets your stream survive something like a quick device rotation without having to completely restart an expensive database query for what is, effectively, the exact same screen. Section 7. The complete model. We've got one view model, one screen, and every tool. Alright, let's put the whole puzzle together. One view model, one screen, and every single tool we've discussed working in perfect harmony. Here's how it flows. Your repository returns a cold flow. The view model takes that, calls StateIn using while subscribed 5000, and boom, a hot state flow emerges. The UI then collects it, meaning it reads the current state the literal moment it subscribes, and then gets every single future change automatically. Now, let's say a payment succeeds. The view model emits that event via a mutable shared flow. Suddenly, your UI, your analytics, and your logger all catch it and react simultaneously. Next, a specific navigation command gets triggered. That goes straight through a channel. One specific destination consumed exactly once and completely unreachable by any other collector. So, let's summarize. Flow moves data. StateFlow holds it. SharedFlow broadcasts events to many listeners, and Channel delivers one value to one specific receiver. You see, these aren't just 4 separate, random APIs. They are one cohesive reactive model. Data flows from a source, gets held in state, and dispatches events to exactly the right consumers. And that's it. That is the full picture. Remember, every single concept we covered in this explainer has its own dedicated short in our 29-part series. Each one is under 90 seconds, breaking down a single mental model, and they all build on the last one. If you want to really master every single detail, start right at short 1. You'll find the full playlist linked in the description below. Also, I want to let you know that a long-form deep dive series is coming very soon. We're talking full explainers, way more code, production patterns, and real-world architecture. So make sure you hit subscribe so you don't miss any of that. This is Android Atlas. Oh, and before we go, with all these incredible tools now clearly on your belt, which reactive pattern are you going to master first?